Hello and welcome to Unit 6, Inverse and Radical Functions. Our first lesson for this unit is on operations of functions. So we can have functions, so like f of x equals x plus 2. We're going to be working with those and we're going to be combining multiple functions using addition, subtraction, multiplication, and division, and also evaluating. So your warm-up is given the function f of x equals 4x minus 5. What is the output or y value when x equals negative 3? I want you to try this problem on your own, and we will go over it in class. And so it should be pretty straightforward, but pause the video and try it. Hopefully you actually did pause the video. Here we go. We're actually going to start it. So our definition for this lesson is composition of functions. It's an operation that uses the results of one function to evaluate a second function. And so what we're going to start with, though, is we need to understand what operations on functions we can do. So we can have this fancy notation where it's f plus g of x. And so all it's really saying is you're taking f of x and adding it to g of x. Likewise, if we're subtracting them, we're just going to subtract the functions with each other. Don't forget that we have to distribute that negative in. Then we are going to multiply functions. So this one you can either use double distribution, or you can use box method. Your parents also probably know FOIL. You could use FOIL. We were just kind of going away from it. And then dividing fractions. And look at that. We have an excluded value from Unit 6. Or, oopsies, Unit 9. And so we're going to do this problem together. Example 1. So we're given these functions and we're asked to find the following. So we're given f plus g of x. So we're going to find f of x plus g of x. And so f of x is 2x plus g of x, which is negative 4x plus 5. Combining like terms will give us negative 2x plus 5. It's as easy as that. It's just new notation that we're bringing into play. And so our next one, we have f of x minus g of x. Now, eventually you won't have to write this, but it is good for notes to see where everything's coming from. So f of x is 2x minus, now remember when we subtract, we want to subtract that whole term. So I want to put parentheses around that negative 4x plus 5. Because now I'm going to have to distribute it in to get 2x plus 4x minus 5. So combining our like terms will give us now 6x minus 5. Okay, we're now going to multiply. So for this one, we have f of x times g of x, which would be 2x times negative 4x plus 5. We're now going to, in this case, all we have to do is distribute in, which would give us negative 8x squared plus 10x, because we have x times x. And the last one we're going to do is f of x over g of x. So f of x is 2x over negative 4x plus 5. Now, there's nothing we can really simplify it, but we can add that x cannot equal. So I'm going to write this over to the side just in case we forgot how to find an excluded value. I'm going to isolate x, so negative 4x equals negative 5. And then dividing both sides by negative 4, we would get that x now cannot equal positive 5/4, because a negative divided by negative is a positive. And that is operations with functions. Let's go on to the next page. Okay, let's look at example 2. So for example 2, we're going to do f of x plus g of x. So I'm going to run out of room if I start there. So we got x squared plus 3x plus 1 plus 2x minus 4. When we add them together, we get x squared plus 5x minus 3. And there's nothing more we can do. There we go. So now let's look at our next one. We're going to take our f function. So x squared plus 3x plus 1. and subtract that entire g of x function. And so you're going to be very careful with this problem because we have to change the signs of everything on the inside. And so when we combine, we would get x squared plus x plus 5 as our answer. Our next one, we're going to be multiplying them together. So we have x squared plus 3x plus 1 times 2x minus 4. Now, if you've been in my class, you know I like the box method. So I'm going to do the box method for this one. So I'm going to make it a 2 by 3 box. And so we have 2x minus 4, x squared plus 3x plus 1. Remember, you can do it either way, meaning you could have had it at 3 by 2 because multiplication is commutative. And so what we're going to do now is we're going to multiply in. So we get 2x squared plus 6x, oopsies, yeah, x cubed, I caught it, plus 2x. Then I'm going to have minus 4x squared minus 12x minus 4. Combining my like terms, so like terms are usually on the diagonal, that's why I like this method. And so we get 2x cubed plus, oopsies, 2x squared minus 10x minus 4. We could technically factor out a GCF, but that's not what it's asking. There we go. So there's our answer. And then our last one we're going to do is we're going to take our f of x term, so x squared plus 3x plus 1, and divide it by our g of x term, so 2x minus 4, which there's nothing more we could do. And so x cannot equal 4 divided by 2 is 2. Okay. For example 3, I would like you to try this one on your own, and we will go over it in class. So example 3 is on your own. But what we're going to do now is we're going to move into our next section, unless you want to pause the video and finish example 3. Here we go. We can also evaluate at a specific value given f of x equals x squared minus 4 and g of x equals x plus 2. So we're going to find the following. So the big thing here is you just need to be aware of which function it's giving. So remember, the letter in front, this is the name of the equation. So this is the f function. For a, we're working with the f function. And so if you notice, x has been replaced with 3. So that's what we're going to do with our equation. We're going to replace x with 3. Now I want to make sure I don't lose parentheses because if it's negative, it causes problems. If it's squared, it causes even more problems. So whenever we substitute, we want parentheses around it. So we get 9 minus 4, which is 5. Then we have g of negative 2. So this is using our g function. So we get negative 2 plus 2, which negative 2 plus 2 is 0. And then we're going to have f of 5. So we're going to have 5 squared minus 4. 25 minus 4 is 21. And then this one is asking for a little bit more. It's asking us to find two pieces. So f of 1, so that would be 1 squared minus 4 is negative 3. And then g of 2, we're going to get 2 plus 2, which is 4. Now we can't forget that we're subtracting these, so negative 3 minus 4 is negative 7. Okay, so we can do operations with evaluating functions. So let's go to example 5. Now these are a little bit more difficult, and so we're going to still evaluate each piece and then do the operation between them. So h of 3, h of 3 is 4 times 3, which is 12. And then g of 1, so that's 3 times 1 minus 1. So 3 times 1 is 3. Minus 1 is 2. We are multiplying them. So 12 times 2 is 24. Okay, let's try our next one. So b, g of 2. So 3 times 2 minus 1. 6 minus 1 is 5. So we get 5. H of negative 1 is 4 times negative 1. This is where you got to be very careful because this is negative 4. And we're going to be adding these together to get positive 1. Now, C looks a little funky. It's because it's saying 3 times h of 1. Well, h of 1 is 4 times 1, which is 4. So 3 times 4 is 12. Okay, so that's just evaluating at a specific value. The reason that we need to know this is for this new thing that we're going to be talking about, which is composition of functions. So composition of functions is our definition for the lesson, substituting one function into the other. So this right here is a big piece, okay? They look the same. The only difference is the order that first parenthesis shows up in. And so how it's stated, I'm going to say it right now. So f of g of x is stated as f of g of x. If you want to think about it, each set of ofs goes with a group of parentheses. Okay, and so then there should be an extra parenthesis. G of f of x is stated as g of f of x. And so what this is doing is you are plugging in a value or a function into another function for x. Kind of like what we did in example 4 and 5, except instead of just plugging in a value, we're going to be plugging in a function. And so it can show up in a bunch of different ways up here. I personally like to rewrite it just because I'm a little bit more of a visual person, because I can see, oh, I'm plugging in g of x in for x of the f function. So what that means is we're going to take the g of x function and we are going to plug it in for x into the f function. So we get 2 times 3x minus 5, which is 6x minus 5. That's it. Now I am asking for the domain. Well, if you think about this function, it's a linear function. Here's our y-intercept is -5. It's a positive slope. And since it's linear, our domain is always just going to be -infinity to infinity. So let's look at B. So this, again, I like to rewrite f of h of x. So that means we're going to take the h of x function and we're going to plug it in for x into the f function. So what we get is 2 times x squared plus 9 minus 5. And so when we distribute in, we would get 2x squared plus 18 minus 5. Combining like terms, we would get 2x squared plus 13. Now, the x squared might be a little problematic for some people. However, if we think about this, it's a bad graph. Our graph would look something like this. There's our y-intercept, and so it doesn't actually really matter because it's a quadratic, and a quadratic, no matter what you do, will always be -infinity to infinity. Now, I'm not going to say always your domain is -infinity to infinity, but if you think about transformations, a lot of the time, no matter what we did, unless it was like range sometimes, it was usually -infinity to infinity. So now what we're going to do is we're going to go to example 7 and do some practice problems, and this is our last page, so here we go. So we're doing f of g of 1. You can do this a couple ways. So you can actually take the g of x function, plug it in for 5, or for 5 of x, and plug in 1 and all that stuff. What I suggest people do is first find out what g of 1 equals. So g of 1 is 2 times 1 minus 1, which is 1. So what we're going to do is now we can use substitution. So since g of 1 is 1, we can substitute and find f of 1. So f of 1 now is 5 times 1, which is 5. And so for our final answer for A is 5. The other way that you can do it is, here we go, we're working with the h function, we're plugging in, so 5 parenthesis 1 squared minus 4 times 1 plus 3. So what I've done is I plugged in negative 1 into the h function wherever there's a x, and I plugged that function in for x into the f of x function. Whew. And so I can, I guess, simplify here. So I get 1 plus 4 plus 3, which is 8. So 5 times 8 is 40. That's another way that you can do it. I personally like what we did in A, just a preference. And so let's do C. Again, I personally like to rewrite it. So what we're going to do, I'm going to do that first method again. So g of negative 6 is, always be aware of the names of the graph or the functions, because it can start to get a little difficult. So we get negative 12 minus 1, which is negative 13. So what that means is we're now going to be finding f of negative 13. And our f function is 5x. So 5 times negative 13 is negative 65. Our last one we're going to do is g of h of 2. So h of 2, we're using our h function. So we get 2 squared minus 4, oopsies, not x, because we're replacing x with 2 plus 3. I'm going to do it by hand because it's always good to practice that. So we get 4 minus 8 plus 3, which is negative 1. So what that means now is I'm finding g of negative 1. Our g function is 2x minus 1. So 2x, which is now negative 1 minus 1, is negative 2 minus 1, which is negative 3. So there are operations and compositions of functions. We are going to expand more on radical and inverse functions later in the unit. Please come to class with example 3 done and your questions. Look forward to it.